Let's take a look at a few examples. This example, it says determine the characteristics of the image formed by a concave mirror when the object is between the center of curvature and the focal point. So we have a concave mirror, and this black line means I want my mirror to be here, just because I know then we'll have room to draw the image. And it doesn't say where the object is at all, so I'm just going to draw the object right here. And I'm going to say that the focal point is right here. That means that the center of curvature is right here. So this is F over here. This is C over here. So remember our steps for drawing the ray diagram. You draw your mirror, draw your focal point, center of curvature, you draw your object, and then you go ahead and draw the three rays. So the first ray is ray number 1, which is parallel to the optical axis. Whoops. Try to draw a line here. If I click on the object, it wants to drag that one around. So I have to draw my line and then move it down here. All right, so you draw your line parallel, and that first one was orange, and then it's going to reflect through that focal point. So again, I have to just start it somewhere else so that I can drag it. It's just this software here. But I want it to reflect through that focal point, so I'm gonna make it reflect through that focal point as big as I can through that focal point right there. So that's ray number 1. Ray number 2 said that it goes through the focal point and then reflects parallel. So I'm going to drag this right here. It's going to always originate from the tip of the object, and I'm going to make it go through that focal point. And then as soon as it hits the mirror, that's where it's going to reflect parallel. And I like to use purple for that ray number 2. That's why I have the color codes. All right, so that ray is going to reflect parallel. So you can already kind of see exactly where these rays are intersecting to form the image. Now I can see here that this ray was a little bit off here. There, that's better. And then the third ray is going to appear to come from the center of curvature. It can't go through it because the center of curvature is in front of the object here, but it's going to appear to come from it. So let's go ahead and adjust that ray just a little bit there. All right, so, and as soon as it hits the mirror, what's going to happen? It's going to reflect right back on itself. I like to use a blue one here. So basically all I have to do is just extend that ray in the other direction. But I like to have all the arrows always pointing in the correct direction here. So let's grab this one over here. Just have that same exact direction as before. And what we can see, again, it's not perfect, but that's the blue one over here. And then this one over here was the purple one. So you see the three rays are all intersecting at this point right here. So the last thing that you do then is you draw your image. You always start it from the optical axis, and then you go wherever those points intersect. So they intersect right here. So that means that your image is pointing down here. So then what you do is you figure, okay, well, what are the characteristics of this image? So what we see is that it's a real image because the rays actually intersected. It was bigger than the object, and it was also inverted. It was upside down. So the reason for this example is because we saw earlier, we were told that when the object distance P is greater than F for a concave mirror, we were told that the image was always going to be real and inverted, but we said sometimes it was smaller than the object, sometimes it was bigger. So it's smaller if the object is over here somewhere further than the center of curvature. But if the object is between the focal point and the center of curvature, you can see here that it forms a bigger image. So finally, let's look at a few more quick conceptual questions just to kind of remember the properties formed by these different mirrors. So this first one here says, okay, which type of mirror is this? So you're supposed to be able to tell just from kind of looking at the type of image that is formed, but you might be able to just see the mirror and see, oh, well, that's obviously a concave because of its curvature. But another reason that we know that it's concave is because the image was inverted. You saw that it was kind of hard to tell, was it bigger or smaller? It was around the same size, but it was definitely inverted. And it was the concave mirrors that formed the inverted images. And then the next question, what type of mirror is this? Well, this mirror is forming an upright image. So that's how we know it's convex, but also we can just look at the curvature of it. It's like looking at a Christmas tree ornament. But we can see back from our ray diagram for convex mirrors that the image was always upright for convex mirrors. And now this one, however, so for the convex mirrors, the image is always smaller than the object. Now if we look at this one over here, it's upright, but it's also a concave mirror. Concave mirrors can form upright or inverted images, but if they form the upright images, that's only when the object, you can see the object here is placed very close to the mirror. This is when the mirror acts as a cosmetic mirror. This is the case that we saw here. When the object was closer than the focal point, then it formed that virtual upright image.